recharging through existing open dug wells. There are several dug wells in the state. In Andhra Pradesh, it is estimated that there are about 16 lakh dug wells. Many of these dug wells presently are dry or with deep water levels. These open dug wells can be utilized for recharging purposes, and that can be done by collecting the rainfall runoff occurring in the farmer's lands in his own holdings and diverting it through a channel into the well. When the rainfall runoff has to be admitted into a well, there are two important things that have to be considered. One is the runoff water should not carry any silt or sand when it enters the well. The second thing is that when the water falls into the well, it should fall into the water body of the well, but not on the sides of the well. When it enters or falls on the sides of the well, it will lead to erosion of the sides and deposition of silt within the well. Under no circumstance the transport of silt or sand should not be done into the well through such collection, drain and admission into the well. To facilitate this type of situation, that is to prevent the carrying of silt and sand through open drains into the well, a simple structure has been designed. The cost of the structure would be around 400 to 600 rupees, including the cost of the pipe, whereas the amount of recharge that would be occurring in the well would be quite significant. Generally, it works out to something like 1 to 2 rupees per cubic meter of water stored. It gets stored number of times, and number of times it gets refilled with water. So, therefore, it can be calculated what is the cost per 1 cubic meter of recharge. But if you have to calculate on the stored volume, it varies from 1 rupee to 2 rupees per cubic meter, depending upon the size of the well. Comparatively, when we see the mini percolation tank or any other device, they are costing more, something like 5 to 10 rupees per cubic meter. But this is working out very low cost because the well is already there. It is not as if we have to excavate a well. It is only a question of admission of water into the well. So, therefore, it is highly economical. And the amount of recharge that takes place through such dug wells is significantly more than any other structure. That is because in the dug well we have the vertical sides or sloping sides, which can also facilitate seepage of water much more effectively than any other structure, and it has got fissured formations at the bottom, which encourages the deep percolation. And actually it is seen when the well gets filled up with the rainfall runoff, it disappears in a matter of 15 days to 1 month, depending upon the water table level there. And this recharges the water table in the entire terrain. It is something like recharge occurring through a device like mini percolation tank or percolation tank. And this is also one such device which recharges to the water table. It raises the water table. And let us now go through the technical details of such recharge device. This would be a diversion drain, draining water coming from the farmer's holding. It could be something like 4 acres or 3 acres or whatever holding he has or whatever water he would like to divert from even the neighboring fields also, he can divert it to this canal. And this canal enters a small silt trap, of dimension 0.5 meter by 0.5 meter and a depth of 0.3 meters. So, this is the silt trap, and when the silt trap is filled with water, it overflows and enters this sump. It is a circular sump, and the water gets stored here, and the water is drawn out through a 100 mm pipe, could be rigid PVC or asbestos cement pipes, and it is taken into the well. This is the dug well, and terminated at a point where the water, when falls, would directly hit against the water body. It should not be terminated here, because when the water falls, it will flow on the sides of the well and it will erode the sides, eventually silting the well. So, these are the basic details, and this structure as seen in the cross section would be something like this. This is the channel or the drain which drains the storm or the rainwater runoff in the farmer's field as well as his neighboring field, in case he wants to divert that. So, this is the diversion drain which enters the silt trap. Silt trap is 0.5 meter width and 0.5 meter length, and it is having a depth of 0.3 meters. Silt will get collected here and water will overflow onto the sump. The sump is having a side slope of 1:1 in ordinary soils and a bottom width of 0.5 meter, and this is the side slope of the sump. This sump is circular, as we have seen in the plan, and it is having revetment on the entry side. If we do not have the revetment, when the water flows on the slope of the sump, it will erode the sump sides. Therefore, this revetment is necessary. Also, when the water falls initially, there would be a drop when the sump is empty, and there would be scour at the bottom. So, to prevent that, the bottom also is paved with rough stone without using any cement or sand. And as it gets filled up, the water level reaches here, and the pipe is fixed at this level, about 0.7 meter lower than the ground, and the pipe is taken out like this and water falls. This is kept at 0.7 meter below ground level in order to create a 0.6 meter head of flow, which will create sufficient amount of velocity to take a discharge of about 1 cubic through a 100 mm or 4-inch diameter pipe. So, 1 cubic of flow is quite significant, and if any higher inflow occurs, then we should have a device to divert or bypass that. Otherwise, this will get filled up and may spill over, may overflow and also erode the well. So, we should have a bypass arrangement when higher flow is received, when greater flow is received. That bypass is indicated in the plan. This is the silt trap and this is the bypass. The bypass is obstructed initially through a stone obstruction, rough stone obstruction. If the incoming flow is more, then these stones will be removed and the water flows like this. This can be adjusted to see that only the excess flow which cannot be allowed to enter the well, only such excess flows only are diverted. If supposing we divert more flow here, then the flow here gets reduced and there won't be adequate inflow into the well. So, we have to maintain this level virtually constant in the sump by adjusting the bypass in case there is more flow received. In the case of lesser flow than 1 cubic, there is no necessity to operate this at all. Whatever water comes here would find an entry into the well. The cost of this structure, the sump, this revetment and this silt trap and the pipe works out to anything between 400 to 600 rupees. It is a very cheap device for recharging the groundwater. To excavate this sort of a circular sump to this slope, the construction method is given here. We have to excavate in steps like this, shown in dotted line, and then remove these portions and make the side slope to this line. This is only to facilitate easy execution of work in the field. Such a device, wherever executed, would arrest the flow of silt into the well. It traps here in the silt trap. In addition to silt trap, if supposing some silt comes and settles in the sump, up to this level it can settle down, and the pipe is at a higher level than the bottom of the sump. So therefore, there is a silt storage provision within the sump as well as in the silt trap. When such siltation occurs, the farmer who is in charge of this well would have to remove this silt here as well as here, and then he can use the silt for improving the fertility of his lands. So this sort of a structure is recommended for all the dug wells in the state that are located in the uplands. There is no need for such structures for wells in the command area of tanks or the command area of major areas of project. This is very useful for a farmer having a well in upland areas, and this can be done by the farmer himself without the cooperation of the neighboring farmers, because the cost of work is as low as 500 to 600 rupees, and it is a very simple and small work benefiting his own well.